Good morning, students.
Good morning, Mr. Tench.
Wow, you know my name. Okay, that's good. I am here to give you a class on the topic of fractions. Does that seem strange to you or something unfamiliar to you? Good. So let me start by asking you to just pay attention to the monitor up there. And it has the first slide, which is indicating perhaps the same thing I asked you, if you're familiar with fractions. Anything less than a whole or unity is called a fraction. And to understand the concept of a fraction, you have to think of the whole. Now, I have here this crate of eggs, yes. And the crate of eggs, or the box of eggs, is made up of parts or pieces. So, can anybody tell me how many eggs are in this box of eggs?
12.
Yes. 12, okay. So you could say, like the slide says, there is a box of 12 eggs, one box of 12 eggs. And if I asked you, I'll pick one of students here, to take 3 eggs out of the box. Do I still have a box of 12 eggs? How many eggs did he take out?
3.
So he took out a fraction of the 12 eggs. So he took out, the box came with 12 eggs when I started. He took out 3 of the 12 eggs. So he took out that fraction, okay? So this brings up the idea of fraction. He took out 3 out of the 12 eggs. I might ask you another question. How many eggs are remaining in the box? Yes? 9? Okay. So, what's your name? Sorry? Garen. Okay, so Garen says there are 9 eggs left out of the 12 eggs. Is this also a fraction?
Yes, sir.
Good. So that's the idea behind talking about, can you just put them back in for me? Yeah. So that explains the concept of fractions. And I have other examples there. You can have a box of crayons. You can have a box of pizza. I also have a pizza here, but this is a pizza made up of how many slices? 6 slices. So the entire pizza would represent the whole. And if you add 2 of the 6 slices, you would have eaten a fraction being 2 out of the 6. Correct. Okay. So in a more graphic form, this is the idea of a fraction. A fraction is made up of a top part called the numerator and the bottom part called the denominator. The denominator in this case, for this manipulative of 6 slices, would be 6. So the denominator for this pizza pie would be 6. And depending on how many fractions of the pizza you take out, that represent the numerator, okay? Okay, now I'm going to move into another topic called mixed numbers or mixed fractions. The idea of mixed numbers involves fractions. So whenever you have a, a number made up of a whole number plus a fraction, you define that number as a mixed number or mixed fraction. So in the example there, it says you have a mixed number be in this case, so the number that they gave you was 5 3/4. This entire number is represented as a mixed number, or sometimes called mixed fraction. Why? Because it's made up of a whole number in this part and a fraction in this part. Okay? And an important thing to note, when you're talking about a mixed number comes under the category of what are called proper fractions, proper fractions. So you have the fractional part of the mixed number would be a proper fraction, which means it's less than 1 or 1 whole. And the proper fraction would have the numerator always be in less than 1. Less than 1. So if the numerator is less than the numerator, so in a proper fraction, the numerator will always be less than the denominator. So in this example here, in this mixed number, the fractional part will always have to be less than 1 for it to be called a mixed number or a mixed fraction. Very important. They give you the two examples there, 3/7 and 11/15. And this is more or less the definition. A mixed number is composed of an integer and a mixed number cannot be composed of a whole number and an improper fraction. So earlier I told you a mixed number is represents what's called a proper fraction. If the mixed number has a denominator or numerator greater than 1, then that is calling it a improper fraction, and therefore it cannot be called a mixed number. So to turn an improper fraction into a mixed number, you have to correct it. So the example they give you there is the example they gave you there is 5 5/4. Notice the numerator in the fraction is greater than the denominator. So this is what you would call an improper fraction. Improper fraction, along with a whole number, cannot be considered a mixed number. Clear?
Yes, sir.
Good. All right. So this graphic here brings it home quite clearly, the idea of what is a mixed number. It's made up of a whole number and a proper fraction. Proper fraction being the fact that the numerator will always be less than the denominator. Okay? So I have a little exercise I want to share with you guys. Okay. You can take your time and try this exercise. There are 6 questions. The instructions are there, but you're supposed to answer the 6 questions. Sorry. I'll give you 10 minutes to try, starting. Okay, so I'll just read the instructions quickly for you. It's multiple choice. So you have 6 questions. The first one is asking, it says, Craig filled his car with 15 gallons of gas. His wife drove the car and used 7 gallons of the gas. What fraction of the gas did she use? And you have 4 choices. Circle the right choice. And then the next question, which fraction names the total among shaded? Which fraction names the total among shaded? The third one is asking the same thing. Which part shows 10/7 of the total among shaded? Which part shows 10/7 of the total among shaded? And the fourth, Bernice cuts 2 sandwiches into fourths. She ate one of the fourth. Which of these names the amount not eaten as a mixed number and as an improper fraction? Number 5, Tony ran 1/8 of a mile. Rashid ran 1/4 of a mile. Mike ran 1/5 of a mile. And Carl ran 1/3 of a mile. Which runner ran the greatest distance? And number 6, Bonita's recipe calls for 1 2/3 cups of flour. She has 1/3 cup measure. How many times will she have to fill the 1/3 cup measure? Who's finished? Anybody's finished? Okay. Let me have a look at your paper. Okay. You finished? Okay. Anybody? Oh. Thank you. Okay. Oh, is that next one? You can keep that one. Okay. All right. So what I'll do, I'll check these papers and give you your grade. So those of you who wrote your names, I'll be able to give. But I want to reward all the students who completed the exercise with a little gift. So Helen, okay. There's a paper here with no name. Joel, okay. Thivika Thadani. I know I butchered your name, but sorry. Daniel Medina. Okay. And I still have two papers with no names. Oh, you, no, you were, okay. You're Carson, right? Okay, okay. All right, so let's move on with the lecture. So we've covered the topic of mixed numbers. And I mentioned to you that an improper fraction would be a fraction where the numerator is greater than the denominator. So you have the example there, you have the number 7/3, and that is the example of an improper fraction because the 7 is greater the 7 in the numerator is greater than the 3 in the denominator. And we could see it even more clearly in this example here, where you have an improper fraction made up of three circles, and they're divided into thirds. So graphically, 7/3 would be represented by the 3-slice pie. 3 slices pie, 2 of the pies are completely covered, and a third of the third pie is covered. So that's an example of an improper fraction. I want to go into one use of mixed numbers, which is the addition of mixed numbers. Just like how you can add whole numbers, you should be able to add fractions, and mixed numbers is an example of a number that you will encounter situations where you want to add a mixed number. Now, in the addition of mixed numbers, there are several steps you have to go through. And in the example they give you here is, and remember that a mixed number is made up of a whole and its fractional part. So you want to add this mixed number, 3 1/2 and 5 2/3. Okay? So the first step you would go through when you are adding mixed numbers would be to separate the whole numbers. So in this fraction, the 3 is a whole number. In this fraction, the 5 is a whole number. So you would take the 3 and the 5, put them aside, and then you concentrate on the fractions. So you're left with 1/2 and 2/3. So you want to find the sum when you add those two proper fractions. Now, are the denominators in these fractions the same? No. So you have to do something else. Huh? You have to look for what's called the, yes, multiply by, could you repeat? It sounds like you're right. I just didn't hear you. Which number? The numerator or the denominator? Correct. So she's suggesting that to find the sum for these two proper fractions, you will have to multiply both numbers by what's called an equivalent fraction. A fraction that on both sides will make the denominator the same. So we could guess at that? Yes. Okay, you're suggesting 6 for the top and 6 for the bottom. So let's see if that works. So for this one, it will be 6 over 12 plus 12 over 18. The denominators are not the same. So that equivalent fraction wouldn't work. Any other ideas? Yes. Okay, he's saying 2. There are actually several methods you can use to solve the proper fraction. But this is one of them. And so you're saying 2 over 6 plus 4 over 6. Aha! You got the same denominator. So that makes it easier to add the proper fraction. So we'll immediately put our denominator as 6. 2 plus 4? 6. And reduce it to its lowest would be? 6 over 6 would be? Okay, I'm getting mixed signals. Yes, what do you say? Huh? Okay, I didn't hear you clearly.
You have to reduce the fraction into its
Right, which becomes? 6 over 6 becomes? Yes, help her. Huh? Okay, just one. Okay, so I have found the sum for the fractions. Now, I have to, remember I moved the whole numbers aside, so what I'll have to do is add three, the three numbers, the whole number, 3 plus 5 plus 1, which gives me 9. Let's see if you all are correct. So, that saves me having to actually explain this if your answer is correct. All right. Six. I'm sorry. Okay, they say the answer there is 9 and 1/6. Okay. 3 plus 5, and the remaining fraction is 1/6. All right. So, 2/3. So if I did this, it becomes, oh, it's not 2. This would have, the 2 would have given the denominator as 4, and so that wouldn't work. So that, my bad, I multiplied wrongly. But anyway, you're close, because it says here, when you add the fractions plus 2/3, you get that as your number, 7/6. And 7/6 is an example of an improper fraction because the numerator is greater than the denominator. So you have to turn this into a mixed number by dividing 6 into 7, and you will get 1 and 1/6. Okay? So convert that to a mixed number. So you will now add 3 plus 5 plus 1 and 1/6. So the 3 is a whole number, the 5 is a whole number, the 1 is a whole number, so that gives you 9. I'm sorry. So that gives you 9 and 1/6 as your final answer when you add two mixed numbers. Now, the same process can be applied to the subtraction of mixed numbers. So I'll go through as best as I can the same exercise in the case of subtraction. In the case of subtraction, just like how we did with addition, first thing we subtract the whole numbers. So the first step would be to subtract the whole numbers. Then the second step would be to subtract the fractions. In the example I showed you, I was adding whole numbers and fractions. In subtraction, it's just the reverse. You're subtracting whole numbers and subtracting fractions. Then you write the mixed number with the wholes and the fractions. Okay, so they have the example there. So let's look at the example they give you. You want to subtract 5 and 3/5, 3 and 1/5 from 5 and 3/5. So the first step would be to subtract the whole numbers. So let's... Can I get a volunteer to guide me through this? Yes, come. All right. So I'll just write the fraction here, 5 and 3/5. minus 3 and 1/5. Okay, I want you to write the first step. What is going to be your first step in doing the subtraction of these mixed numbers?
Separate them.
Separate what?
Separate the fractions and the whole numbers.
Yeah, okay. Good. Okay, you want to try the next step?
Subtract.
Okay, the 5 would be what? Your denominator. Good. Keep going. Okay, he's saying he has found the proper fraction once he subtracted the 3/5, the 1/5 from the 3/5. He's already moved the whole numbers out of the way, and now he's going to do the subtraction of the whole numbers. So when you subtract the whole numbers, what do you get? He says when you subtract 3 from 5, you get 2. So his proper fraction for the fraction was 2/5. Okay, so now you're left with putting your final answer. Good. Thank you. Don't go. For your wonderful efforts. Okay, so you see, that in a nutshell would be the process you go through when you do subtraction, as well as in the first example where I walked you through doing the addition of mixed numbers. Now, there will come situations where it would not work out so easy as he found out, where the denominators for the subtraction were the same. So that made the whole process easier. So there are steps you can use when you're subtracting mixed numbers with different denominators. And the steps are there. First thing, convert the mixed numbers into improper fractions. Find the common multiple of both numbers. Convert the fractions as common denominators. Solve the fractions, and then convert the fraction back to a mixed number. Okay, so that's taking a little further, warning you that it can get more complicated than the simple examples I showed you. Okay, so I want to thank you all for your wonderful attention. I have another exercise I will leave with Mrs. Borden to give you all, and then she'll return the papers to me, and I will see how much of a success my in-class lecture was. So I just want to say thanks, Mrs. Borden, and I don't remember Mrs. Lopez and Mrs. Yeah, for your wonderful assistance. Thank you, students.
Thank you.
Okay.